Yeah, I've got this LOMBEX LUX Nova light. Quite an expensive light actually. They're about 25 quid on eBay. £30 for a pair probably. And this one's been going for 3 or 4 months and it's gone wrong. And so can't have been used for more than about 40 hours, so it's pretty awful. Anyway, it's dead as a dodo. There's nothing coming out of it. I think it's a quality thing, but yeah, not working. So time to have a look, see what's going on with it. Looks like it's probably just a standard type of light inside, but they've just, hyped it up a lot and just made it seem a better quality item than it is. So zoom in a bit so you can see. It said CE FCC. Oh yeah, and it's got ROHS. It's got a little wheelie bin thing laser printed on it, so it all must be true, mustn't it? Because it does come from China, so there's not going to be any claims on the label. It really is quite heavy actually. I weighed it in the kitchen. It was like 220 grams, so there's something in there that makes it feel quite heavy. I'm not sure what. Certainly isn't electronics, and it isn't LEDs. It's something else in there. There's not a transformer, I don't think. So yeah, quite a chunky thing. Wow. Anyway, let's have a look at it, shall we? Yeah, so she's plugged into the measured volts, and as we said, nothing happening. It's taking on the power meter it says 1 milliamp, but nothing happening. Dead as a dodo. So yeah, it's cost about £1 an hour, I think. This bought 50 pence an hour before it failed. What a waste of materials, going straight into the landfill had I not intervened. So let's have a look at her and see what's inside. Yeah, this thing is really quite weighty actually. I'm dying to see what's in there. So let's, it's really heavy. So let's give it a go. See if we can get it off. Oh, it's tight. Oh, it's coming. There we are. So nice opaque dome that soaks up half the light, and then inside we've got, what have we got? Have a closer look at that. There's the LEDs and colour. It looks like tricolour LEDs and some white LEDs. We've got 1, 2, 3, 4, 5, 6, 7, 8. No, 7 colour LEDs. Tricolour, red, green, blue. Got a metal substrate PCB with the aluminium on the bottom to soak the heat away from the LEDs when they're running to make them longer. And there you can see there's the Wi-Fi antenna on the bound to be certified Wi-Fi module. They make these by the million in China, and they're quite cheap actually, just a few dollars actually, just for the thing that talks to your Wi-Fi. And it seems to be potted in some sort of silicon rubber. You can see the LED boards connected onto the controller by this pin header. It's just a straight through pin header they've used, soldered 5 connections. I have to unsolder that to get it off, aren't I? But yeah, it's actually well potted in there. It's not moving much. So yeah, I don't know if I can get this thing open because it's absolutely full of silicon rubber by the look of it. It's very heavy though. I'm surprised they'd waste that much. Let's take the screws out and have a look. 1. 2. Yeah. Right, I think it's not gonna come off, is it? I'm gonna have to get the solder iron out on that, or cut those pins off to desolder that from there. So, for further ado, let's get the soldering out and turn it on and have a go. Actually, before we do that, let's take this end off. See what's in here. These things just push in and crimp the wire into the plastic like little contact pegs. You just get them out of the pack. Actually, they're quite tight actually. Let's try the other one. Yeah, go the easy one first. Yeah, and you can see the wire there. You can see it. It's just not a very good way of connecting. It's jammed between the plastic and the actual contact. I suppose there's not much current there to do. Let's get the other one out. So that's 1, 2. There's a grain or something falling out of it. What's in there, I wonder? Can you see that? There's something sparkling. I think they filled it with sand or something. Let's have a look at this. Let's get close up and have a look before we actually investigate any more. Right, so here's a real close-up of the rear end, both holes. And there's something in there. That's all it is. It's white and it's crystalline. Is it salt? Let's shake it. Well, look at that. Oh, Jesus. Yeah, it's crushed up something or other. Let's taste it. No. Doesn't taste of anything. It does dissolve. I'm a bit worried now what I've just put in my mouth. There's only 1 grain though. There we go. So we've got a salt shaker. So if we can't fix it, we just fill it with salt and use it as a salt shaker instead. God, there's loads of it. Look at it coming out. This could get boring. If it's full of salt, this is going to take some time. Do you know what? I've seen it all now. I'm new. Fancy filling a product full of sand or whatever it is. Could be sodium chloride or some sort of chloride, because chlorine's heavy and this thing is heavy. Yep. Seen it all. Yep. Keep shaking. I'm going to come back when I've shaken it all out. Well, I've been shaking for 2 or 3 minutes, and I think, yeah, it's just about. Oh no, there's some more in there. Jesus, is this ever going to stop? Okay, so I finally got it all out. Brushed it to one side. What a thing. I think I know what's going on, but I'm not sure. I think they just dumped that all in there as a kind of a filler. Let's take the end off anyway. Let's have a look. Oh, there we go. So that's the cap off, and you can see actually the end of the electronics. See a resistor and some more salt or granular unknown substance. It's probably silica gel, isn't it? It's probably old silica gel that they squashed up they didn't want. I can't think of anything else. It's not ceramic, I don't think. It is some kind of not sugar either, but it feels like it could be sugar, but it isn't. But it's not a crystalline type sodium chloride or anything like that, unless you know better. I could try analysing it, but I don't think I'd get very far. Yeah, I think this is the transition between the grainy stuff that was poured in before they poured in the silicone. It's just grey and crystalline with horrible stuff in it, so I'm going to poke around. I don't think I'm going to get very far. I'm going to dig some of it out, but I'm going to be here forever at this rate. It's amazing what they do to make these things unrepairable. Jesus, look at it. Really gritty indeed. Yeah. Yeah, let's try plan B. Let's take the top bit off instead, shall we? Hold on a second. So here we are, looking from the top again. I'm going to desolder this header from the PCB, well, or the printed circuit board. It is a printed circuit on a metal substrate, aluminium bottom bit to suck the heat away. So, yeah, that's what we'll do. We'll get the soldering iron out and we'll give her a hot bath. Yeah, that silicone stuff kind of peels off. You know, if it was like proper silicone, I wouldn't bother opening this, but I've got a feeling this stuff is going to be not too difficult to separate. I'll just tidy up my bench at the moment. There we are. Keep it nice and clean. Cleanliness is next to godliness, as they say. Right, let's fire up the old soldering iron and get on with her. Yeah. Unsolder those, they're coming. Oh. Yeah. It's that dreaded bloody unleaded solder, a very high melting point on a metal substrate board. You need a decent soldering iron to get these off. I might just end up snipping these actually. They probably will desolder okay. Yeah, let's get the snips out. Hold on a minute. Yeah. Yeah, this is going to do the job. Snip these pins off. Yep. So that's them done. That should just lift off now, I think. Let's have a go. There it comes. Oh, yep, covered in titanium dioxide heatsink compound to soak the heat away from the LEDs into the body of the actual LED light. It's LED light. Yeah, it feels like it's made of lead. It isn't lead though. I think it's steel actually. Big chunk of steel in there. The trouble is when that heats up, you know, it might seem to keep it cool for a while, but when that thing's up to temperature, it's not going to provide any radiation. It'll just get up there and stay up there. You need fins, boys. You need fins to dissipate heat. Yeah, so let's start chopping away at this stuff and see if I can get this thing out. Yeah, I've been chopping for a while, and it's kind of silicon loaded with some kind of ceramic powder. It's kind of gritty and slices more like not really like cheese, like hard cheese really. Well, you can see I've been chopping away for it for about 5 minutes, and I've got a pile of it on the bench. I can't get the stuff out. I wonder if I can just get a longer blade on this, and hold on a second, I'll have a look and see whether I can yeah, here's one. Yeah. Get yourself a knife. Stand by. I'm going to try and separate you from your enclosure. Stuff it down the side and cut around. I'm going to carry on chopping, and I'll be back in a minute. Yeah, so I've been slicing, still got all my fingers, and I've got down into the guts of her. Still covered in rubber. That's how we like it. Let's turn her over and see whether we can get this thing to bloody move or not. I think that's the best bet. Emergency plan B. Yep, I've been hacking away for another 10 minutes or so. This is not a very productive thing to do. But I'm going to try and push it down on the bench, because you look down here, you can see the board sticks out the bottom. So I wonder if I give it a right bit of pressure on it, whether she'll actually come free. Oh, God, blimey, that's tight. No, going to have to stand up for this. Give it the full body weight. Here we go. 1, 2, 3. Oh, I think it moved. It moved. It moved. Look, it's gone through. Yay. Look at my poor hand. Ouch. Yeah, so there it is. And yeah, let's pull it. Let's push it out, I think. It's moved in. We've had some success. What's it going to be like? Is it going to be revealed? Yes. So, that's how you take it apart. It's going to be an hour and a half to get the rubber out, and then 10 minutes to fix it probably, knowing my luck. But heavy old moulding though, that's insert moulded into there. It weighs a ton. It would stay cool for some time, but it's not going to help it stay cool for very long. So only when that heats up, it'll take a long time to heat up and a long time to cool down. But when it reaches thermal equilibrium, the cooling isn't going to be that good, is it? There's no fins or vents or convection at all. It's got to all come out through the casing. This stuff's quite crumbly actually. Let's slice it off and see how we get on with this. See what we can do. Oh dear. I haven't sliced through an inductor or something. Yep. So it's coming off. It's like peeling the skin off a camembert. One of those hardcore cheeses. We like hardcore cheese. Yeah. Oh look, great, look. I've got an imprint of all the electronics. Anyway, I'll carry on with this and I'll come back to you when I've got it all. So here she is, the electronics. More or less rubber free. There's bits of rubber stuck on still, but nothing much. And what do we have here? We have, well, here's where the mains comes in, live and neutral, although that has no meaning because the end cap of this thing is not polarized, so it can go into the bulb socket either way round. But it's all isolated from the user anyway, so it's live and neutral really has no meaning. So it comes in, goes through a 20 ohm inrush limiting resistor presumably, through a fusible resistor, so if there's any catastrophic shorts on this side blows the fuse, through a common mode rejection choke. That's just common mode noise, i.e. noise impressed on both rails will be filtered out and cancelled out by this choke. It will conduct them to each other and block them from going down the mains. It will stop any switching noise from this side going down to the mains into the wiring to be radiated from the wiring, and vice versa. Anything coming up the mains will be blocked by this and a combination of these capacitors. So you've got a bridge rectifier, then you've got a voltage dependent resistor that's connected across the supply, and when the voltage goes too high, i.e. a surge arrives, it conducts a surge, it starts to conduct and shunts the surge. Series inductor, again filtering, another capacitor, so capacitor, capacitor, filter inductor, capacitor, then the switching transformer for the main supply. And is it a buck regulator? I think it's not a it's not, yeah, it's just an ordinary series offline buck regulator from the mains supply. There's only two connections on the coil actually that are connected to anything. So buck regulator,
buck diode, buck regulation management chip, some programming resistors, decoupling capacitor, and then it comes up here to this capacitor here, which is a 470 microfarad 50 volt. So that's the main LED supply, probably supplying 30 or 40 volts, 45 volts to the LED chain. Looking on the other side, we've got a yeah, these are LED drivers. That's the pins that I snipped that went off to the LED board. And here we've got the not Bluetooth. I've got Bluetooth on the brain. Wi-Fi module, and you can see this Wi-Fi module's got application space in it. I've looked this one up. So the application that connects to the internet and controls the lights is actually coded into the processor that does the communications. Obviously, if you've got one powerful processor in there servicing Wi-Fi at very high data rates, then managing a few LEDs and a little application is virtually nothing for it. It can be done on interrupt in its spare time, you know, almost doing nothing. So via these driver ICs, driver FET ICs to the LED chains. Okay, now what we have got on here as well is, what's that? What voltage is that one? Let's pull that out of the way. 6.3 volt capacitor, 330 microfarads. Alright, well these modules run on usually 3.3. Some need a 1.7 as well, but 3.3 volt supply. So that's the reservoir capacitor for this. And these are quite hungry actually. At 3.3 volts, the Wi-Fi module will take something like 70 or 80 milliamps usually. So it's quite a hungry thing. So you need a good source of stable power to power this. So there must be another buck regulator on here, or a regulator. Yeah, there's one. So what have we got? I wonder if that's connected to there. Let's have a quick probe on that just to check. So that's the low side, that's the AC 0 volts there on that pin of that capacitor, and that's the 0 volts, so that must come over here somewhere. Is that it there? No. Oh, it's not beeping. Set it to the right range and you shall be rewarded. It must be that point. Yeah, so that's 0 volts there. Hello, that's a bad solder joint there, fix that. And the power supply voltage for the LEDs on the big capacitor here, let's just meter that and see where that goes. Normally goes to what one, probably pin 5. Yeah, so that's a 6-leg SOT 23-6 or 236 package, buck regulator chip. Power comes in on pin 5, so that must be power 2. Yeah, so this little resistor chain here, these two resistors, you can see them. Should I get you a closer view on that? Probably a good thing, isn't it? So let's just clip the negative lead of the meter onto the negative lead of the capacitor, so we've got ground, so we can just check where ground goes. Okay, so if I touch this, we should get a beep. I do, although a delayed beep from the Mestec. Right, so down here we've got, this is the I think this is a buck regulator coil, buck coil. Take that off there, you can see better. There's your buck coil, buck diode, reservoir capacitor for 3.3 volts probably, and this is going to be running off the main LED supply. So you've got kind of a dual conversion. You're bucking down to 30 or 40 volts, and you're bucking down to 3.3. Clearly you can't do it with a resistive dropper 80 milliamps that just generates so much heat. Okay, there's a bead of solder there, look at that. Gone now. So down here, this is ground. Yeah, ground. Yeah, okay. So this is 1, 2, 3. Yeah, so if that's ground there. There's a resistor divider chain here, look, going to this pin there, going to pin 5. Let's just go on to switch to the positive rail, see where the positive rail goes. Positive rail comes down presumably to this point, pin 5. Yeah, so that's power in. That's where the 33 volts goes into the regulator there. And then we've got a... Don't go to that pin. Okay, yeah. So this is a potential divider, 100k versus 22k. And what that's doing is giving this feed to pin 4, which is the enable pin on this regulator. So we've got power in, enable, and then on this side, this is the feedback circuit there. So this goes to the 3.3 volt rail through a 10D, which is 124k, and then through a 59C, which is about 40k. I'll look it up in a bit. So it goes through there, and this provides the reference voltage back to there. So this is the feedback resistor chain here to this chip, and that goes to pin 3. So the feedback pin is pin 3. There's the boost capacitor, which provides some voltage, some overshoot from the actual buck regulator inductor to drive the FET. So it gives it extra high voltage to turn the FET off quickly. And this capacitor, without this capacitor there, the FET will turn on and off, but it will get quite hot and be very inefficient because it hasn't got the boost voltage. And then we have the buck regulator coming out onto the 3.3 volt capacitor. So that's what we've got. We've got a dual conversion circuit. So at the moment, let's just plug it into the mains. Let's give it some a bit of power, shall we? Hold on a moment, I'll just get the power organised. Alright, so we've got 120 odd volts AC going in. I've got the ground clip clipped onto AC 0 volts again, I think. Hold on, make sure I don't short anything out. Yeah, so it's an AC 0 volts on the negative side of the meter. So I'm just going to, rather than trying to squeeze the meter in, I'm just going to read you out the readings and see what we've got. So on the output from this, go straight to the output of the bridge rectifier. You can see I'm touching this at the moment, but this supply here comes via an isolation transformer, and also it's being connected via a 60 watt bulb at the moment. So let's just see what we've got. Right, so on the DC supply for the LEDs, we've got 34 volts. Okay, so there's 34 volts. So that power supply, this power supply, is working. We have power coming through the big coil on the other side to power the LEDs. So we have power there. Now, looking on this side, we've got the power coming down to that point there, which was pin 5, wasn't it? Yep. We've got 35 volts on there as well, and so that goes to pin 5 on the regulator. Yep. There's very few of these actually SOT 23-6s which will work up to the 30-40 volt mark as an input on that format. So the choice of components is pretty small, so it should be easy enough to locate. And then we had this point here, which is reading 6 volts, is the enable pin, which should be pin 4. Pin 4. Yeah, 6 volts on pin 4. So the question is, what do we have on the buck, on the output from the buck? So the output from the buck is this capacitor here. That's the capacitor on the underside. On the outside, there's the buck regulator diode. And on there, yeah, we've got absolutely nothing on there. Nothing at all. So this power supply, two possibilities. There's a short on this side. Some electronics have gone duff, loading the 3.3 volts, and it's going to be inside. So I'm going to be able to regulate a decoupling capacitor, or a short inside the actual Bluetooth, not Bluetooth, Wi-Fi. I work so much on Bluetooth I get confused. Inside the Wi-Fi module is drawing too much current. So the reason is why is this point there, which is reading nothing at all. It's about 0.1 volts or so. So can't see any obvious solder bridges. So I suspect we've either got a blown buck diode, blown regulator, shorted capacitor, or a blown Wi-Fi module. Place your bets. What do you think? What do you think it is? So let's have a quick look at that. See if we can isolate the cause of this short. So I can disconnect the power at this point. Right. So we're testing across here. Yeah, it's a short. There is definitely a short. It's reading 0.6 ohms. Yeah, so there's a short on the power supply for the 3.3 volts. So either the regulator, the buck diode, or the actual Wi-Fi module. So how do we find out which one it is? We could replace a load of components, but my preferred method I'll show you in a moment, which is to connect some power to it and drive some power in and see what gets hot. It's a very crude method, but I used to work on logic boards with 100, 200 chips on, and if the old 74 logic series went short and there was an overload on the power supply, you could just shove some power in and then literally use your finger as a probe to find out which one was getting hot, and it was that chip. And it was so much quicker than sitting there working out the timing and everything else and loaded logic lines. And you know, we were in production test and we had to get through this stuff, so that's what we used to do. So I'm just going to do that now and you can have a look.
Alright, attaching these wires. Yeah, we'll put the other one on. So that's on the 3.3 volt rail. We've got two wires basically, so we're going to feed a voltage in there and then see if any current can be caused to flow, which it probably can. We can isolate where the short is. It's just a quick and easy way of doing it. You could start changing loaded components, but best find out where the path to ground or the path, the short path is, i.e. where the current's flowing that it shouldn't be. So just clip that on there. I've got 3.3 volts on the between these two crop clips, and I'm clipping the other one on. Alright, let's find out what's gone short, see where the heat's coming from. Get the old thermal camera on the job. Works most of the time, it works. And if you can just see that, I'll just zoom out here. Oh look, yeah. So you can see an image of the board there. It's quite sensitive, this camera. It'll measure a few degrees above ambient, so it's kind of auto adjusts the colour to show the hot spots. If I can just hold it in the right place, you'll be able to see what the hell's going on. You can see, I'll move it over a bit. You can see we've got a hot spot already. You can see that little white spot on the picture. That's where the current power is. The power supply says there's 0.7 watts going in at the moment, and that's where it's ending up, in that spot. So the question is, I can't really feel anything, but it is a very sensitive camera. I suppose if you knew it was warm, you might actually be able to say yeah, but it doesn't feel very warm at all actually. But it is clearly getting the power going in there and being dissipated inside. So just get something to point with. Hold on, there. So if I just point at it, you can see my tweezers coming into frame, and there, that's where we're at. Yeah. So it's the regulator chip. So the regulator chip is shorted. Conclusive. So that's without further ado, let's have a look and see what we can find in terms of what that device actually is. Yeah, so what it is this. It's an MP2451 36 volt switching chip. I think it's this one because the circuit matches by the look of it. Took some finding actually, and you can see oh yeah, look, 1V7 YW, so it's got JG on the end, but basically it's going to be the same thing. Package reference on both types, there's two different types here, is the same. So what have we got? We've got let's just make that a bit bigger so you can see it, and presumably move it over a little bit too, and scroll it up. There, you can see that now. And yeah, so we've got on pin 4 we've got the control line, which is those two dropper resistors and the 33 volt. We've got pin 5, we saw the 33 volt going in. Pin 6 was at 0 volts. Well, if there's a short in there, it's gone kafooey, isn't it? And there's the feedback pin, which is those two resistors. Is it? Well, the different values on this one, because it's set, that's for 5 volts, but we've got was it 40.2 in that one? No, sorry, yeah, it was 59C, wasn't it? 42. So that's that one, 42k, and we've got 124k on there. There's a little coupling cap on there that just improves the coupling to reduce the noise on the output. So there it is. There's your 3-volt from 1.3. It's an MP2451. 2451. I'll go to the rec and see if I've got any of those. I've got thousands of different chips, so I couldn't say whether I actually have one or not, but I'm going to have a look, see if I can rummage one up from somewhere. I can't find the exact chip. This is a 2459, which is the next one up in terms of input voltage and current capability, and it runs at a slower frequency. So this is a 450 kilohertz version, whereas the 2451 on there is a 2 megahertz. So I might need a slightly bigger inductor. I think the 2451 is spec for a 2 millihenry inductor, where this one needs 4.7 to 10 millihenry, microhenry. So I'm going to try. Right, so I've taped her down, stuck her on the bench. I'm going to get some of the old flux and put it on and use the hot air gun to change this chip. So just get the flux. It's Kingo RMA218 BGA flux I use. It's very good stuff. If you like flux, then this is the channel to watch. It makes life so easy. Things go better with flux. Should be our channel slogan. So get the hot air gun. It's set to 340 Celsius, and ow, that's blowing my hand. There's a little hole in the side of the nozzle where it's just jetting around. It's always awkward removing these things when and maintaining the field of view, really. I'll try and concentrate on this. They'll take a while to heat up. It's this evil unleaded solder, so it's got quite a high melting point. And these components also will be stuck on the board because it's a reflow soldered board, so it's a wave soldered actually rather than reflow, should I say. So let's see if we can get it off. Just snap it off. No, it's not going to come. Try again. You have to, sometimes the solder melts, but it's still stuck on with a little blob of epoxy because they are passed through the wave solder upside down. Get some heat onto her and then see if she'll come off this time. There we go, that's it. And you can see the little blob of red epoxy underneath the actual chip. So let's get the other one. Put some flux on the new part just to make sure. More flux, lovely fluxy flux. Keep the board warm while you're at it, and then move in with the new chip. Come on, you bugger. There we are. And don't be too prissy about alignment because the solder surface tension, if you've got flux on there, A, the pins won't short, and B, the surface tension of the solder will pull the component into place. Not quite there yet. There we are. So that's lovely, lovely. So let's give her a bit of a clean off the flux with some isopropyl alcohol, isopropanol, and a toothbrush. Actually, IPA is the stuff that's going in all the hand gel at the moment for the coronavirus anti-bac gel, so I'll be fine because this office is always full of IPA fumes from where I'm cleaning boards. Clean off the flux, so it's all clean now. Let's get on and give her a go. Okay, the power's on, the chip is on, the chips are down, and see what we've got. So, I'll put this on the ground wire and not get a shock. That one there. Keep my head out of it. I noticed my bonce was getting in the way. Where is it? There it is. And here. Yeah, we've got 3.3. If I can get in there, can I? Can you just about see that? I'll turn that off. No, I won't. Looks like we're on fixed something or other. Let's go in there, let's turn on the spot meter, let's make it auto. Twing. Ooh, that's better, isn't it? Up to a point, you're getting a bit of a bleed out on the other one, but yeah, so on that 3.3 now we have 3.3. So it was the chip was blown. I changed the buck diode actually. I've learned from experience that if you have a buck regulator fault, always change the buck diode as well. It's just that I've changed buck regulators and I've it's blown up again, and I go back and the diode's gone, and obviously this shorting through has done something to the diode. I'm not sure whether the diode was the prime mover, but always change the buck diode. So I changed that as well afterwards, and now it's working. So I'm going to put it back together and then I'll give you a short demo when it's done.
Obviously, financially not worth repairing, but makes you wonder if there is a design fault. It's a shame that so much electronics just gets screwed through the sake of one small regulator failing. And that's what you get. The more technology you put into these cheap products, then the more likely they're going to fail, really, bottom line. But nevertheless, anyway, so I think it's fixed. I'm just going to put it back together. Should I do that on camera or not? Or should I just stuff it back together? What I'm going to do is just clean these holes out, put it back into its enclosure. I'm not going to bother with the sand or the silicone if it goes again inside this holder where it's gone. Yeah, there is no board slot in there, look. It's very crappy bloody design, really, to be honest. See, this is a bulb from, that's a pound shop bulb. And you can see, you know, you've got the variation and you've got the size and you've got some ventilation. Okay, there's no holes in this side. But, you know, it's a much thinner and less massive. You'd think the heat would be able to come out of this better than it would out of this solid chunk with very little radiating surface. So I'm doubtful about this. There is a couple of keepers at the bottom, look, so I might just put some glue to keep the board in the keepers, stop it rattling around, and then run it and see what happens. So let's put it back together anyway. So I get the mother sucker out and the Lütkelben, as the Germans would say, soldering iron. A Weller WSP80 90-watt soldering iron, but boy, it does the job. And what we're going to do is just put some of the nice leaded stuff on, just to make an alloy, a low melting point alloy, and see if those pins will come out under suction. I don't know what solder they've used on this, but it seems pretty high melting point stuff, to be honest. Oh look, it's actually not, it's not a hole, it's a plated through hole that's then been machined across the end. So it's a bucket. It's a bucket. I've tried getting PC manufacturers to make my boards like that, and they very rarely get it right. It's something they don't really like doing. There you go, so we're ready to go. You can see that we've got clearance through those holes. Where's the other bit of this? Where's the other bit of this thing? Ooh, it's all covered in goo. Addressed with these things, usually in the switch mode power supply section. Let's face it, switch mode power supplies are very easy to design if you just copy them off the data sheet. Reliable switch mode power supplies are virtually impossible to design. It's an art. And until they get the devices which are much more robust and much more suited to being abused by voltage spikes and overcurrents and running at higher temperatures, you're really going to be in the same old situation, really. So if we get that housing and we stuff that back in there, come on baby, it goes about there, doesn't it? So I'm going to put a bit of glue on there. Actually, you don't need to, do you? Because if I put that back on there like that, wipe the grit off first. Don't want any bits of grit interfering with our mating of the thermally conductive parts. I really should put some more on there, shouldn't I? What do you think? Yeah, let's go and get the goo out of the cupboard. We're going to use the goo. Right, radio spares. Goo me up. Just around this metal ring here. Can I put some goo on? That will improve conductivity. Right, there we are. It's lovely. Actually, this stuff has dried out quite a bit. I wonder how long it's been in stock. Expensive bulb for... They convinced themselves it was worth it, but I don't think so. It goes on there like that, and then squish it on down. and then put the screws back in. Wasn't that far away after all. One screw goes in now, like so. I could just use a bunch of copper wires on there, couldn't I? I could find a pin header. Is that 0.1 inch pitch, do you think? Do you know what? I'm just going to use some bit of copper wire. I have some here, and it's silver, so it will reflect the light back out through the orifice. Right, okay, so we're going across from there to there. Must tidy up my room. Okay. What I'm going to do is, because I'm doing the dunk, the solder and dunk, load the tip and dunk it on, I'm going to put a bit of flux on, because you know what we like. So you see there's the wire. I'm just going to do the other 5 off camera, because otherwise it's going to get very boring. Other 4. 1, 2, 3, 4, other 4. So, yeah, all soldered on. Not the neatest job in the world, but it's an awkward thing, rocking and rolling all over the place. A bit of trim away from the antenna. And a bit of flux just to clean her up. But it is shiny, so more light will be reflected out by my solution than theirs. Okay, and there's the board sticking out the back. So now, if we just put our crop clips on again, the crop clips on there, make sure it's actually on, and this time we'll turn it up to the full chap, 240 of Her Majesty's volts, well 235, there we are. So, keep your mum on speed dial, let's see if she works. Yeah, it's going. I can't see that flickering, you can see it on camera. Yeah, it's working, so it's got a white bulb, fantastic. God, it's flickering pretty bad, isn't it? But yeah, so it's working now, so it's fixed. Alright, so I shall give it back to my son and see whether it works or not. Yeah. Cap on. Came off a lot easier than it goes back on, boys. Any particular way? I don't think so. Let's get it under the rim. There we are. So that's that back on. That's back in position. A spot of glue on there, I think, just to hold it from rattling around. What shall we use? Should we use a bit of the old Araldite? Goddess Edition Araldites. Araldites, I like that, I just made that up, believe it or not. I'm stuck on you, baby. I want a dibber, don't I? I usually use a tie wrap, but there's none around in my pot. That's the trouble with having an office where everyone knows where everything is. I'm so organised in here that anybody wants anything, they just come zooming into my office and steal it, including my bloody tie wraps. But what can you do? You can't complain, because people don't like people that moan, so I'm going to moan online instead. Alright, a little bit of Jubilee in there, a bit of epoxy just to seal her in. Don't think it's going to slip and rattle, but you never know. On there. Put my cap back over the heel. Curious why the white wire is much longer than the black wire. I think that's by design. So the old tweezers. Not too big. Yeah, I want to push that on in the original slots. There we are. So somehow I've got to get that to go back onto there, so stick it on there like that. Give her a bit of a bump. Like that. Lovely. Pull this black wire through far enough to get the locking peg on it. Yes, I can. So now we've got these little dibbers. Do you remember these little rasping things which just fit in there? There's one, and here's the other. I've got to push this white wire back inside so that we've just got the edge of her in position. There we are. So they're all back in, back together. Go and stick it in the bulb socket and I'll report, but I think that's fixed now. It's that regulator. I'm not sure how the cooling is going to work, but we'll find out, won't we? I could backfill it. I mean, if you do fill it with silicone again, use neutral cure silicone with a bit of sand in the bottom like they did. Don't use the acetyl cure silicone because it'll just rot everything away, and the acetic acid that's released will corrode your electronics. But anyway, a shining example of how to fix one of these bulbs. Overpriced and under-engineered is my evaluation of this thing. But anyway, it's fixed, so let's see what happens. I hope you enjoyed watching that. If you want to see more, if you want to help you get to sleep at night, then press the subscribe button down there. So thanks very much.